All axes are prepared. It is time for the frame. Hi, welcome to Slow Engineering. I'm David. With 3 axes complete assembly, it is time to construct the frame to assemble 3 axes together. The build has a frame on the side of the y-axis to build the stand for the x and z-axis. The frame is also using 2060 and 2000 extrusions to make sure it is sturdy. The inner corners are using normal vertical connectors, and outside the frame, I designed a couple of the plastic plates to align and fix the frame. These plates are placed at the outside of the frame. I used the PA12CF cord ABS to enhance both stiffness and creep performance as I tested before. All the plastic parts are made with 100% infill and printed on the glass with PEI. It is important to build them on glass. The glass provides flatter build plate compared to the PEI on spring sheets. The PEI on the spring sheet will deform with the heat bed underneath due to the magnet. As a short video I showed before, the heat bed tends to warp when the temperature rises. If the build plate is aligned with the heat bed, then the build plate will be affected by the heat bed and perform lower flatness. On the other hand, if the build plate is glass and has good distributed heat, the glass can expand more evenly and lose less flatness on the build plate. The thermosilicon pads I used to build my volume provide heat transfer also as a compensate material for different thermal expansion rate of the Mi66 heat bed and the build plate glass. An additional layer on the glass surface is the PEI sheet to provide ABS with good adhesion and prevent terrible warping. In the future, the printed parts that are required for CNC cutting or grinding will also need a reference plane. The plane which contacts the build plate will also become the reference plane for post-processing. Back to the assembly. Install extended frames on both sides of the y-axis. Use 9-edge squares all the time with the glass underneath to make sure all the corners are vertical and aligned to each other. Install the surrounded frames around the y-axis with connectors. After frame assembly, flip the y-axis 90 degrees and tighten the extrusion working platforms on the y-axis platform. Then, upside down the y-axis and face the working platforms to the glass surface. Release all the working platform screws and make them align to the glass. Realign them to each other and tighten them again to make sure the platforms are even. And this is the assembly for the y-axis. Next step is the sub-assembly for the x-axis. Align the vertical connectors with the 9-edge squares on the glass surface. Then, align 2 different lengths of the extrusions on the glass surface and use connected parts to make them into a piece. Next, place them at the side of the x-axis and use vertical connectors to connect it with the x-axis. Make sure the extrusions are aligned when different connectors are used. It is critical to make sure 2 ends of the gantries are fixed on the symmetric positions of the y-axis frame. They are the key to make CNC gantry squares. After the gantry is assembled, connect the entire X gantry to the y-axis frame. Secure the lower parts of the gantry to finish the X and y-axis. The final axis, the Z-axis, is installed on the X-axis. Install all the screws and nuts before the Z-axis is installed. Carefully align the Z-axis to the X-axis platform to finish the Z-axis assembly. Now the outline of the CNC router is complete. Next part will install the motors. I hope you enjoyed this video. Like, share this video and subscribe to this channel if you enjoyed. Or consider becoming a Patreon member to support my projects. Thank you for watching and see you next time.